In this video, we will continue studying some applications of Maxima and Minima. Suppose, for example, that you want to ship your products, and to do so you want to use boxes of, let's say, S by S by L inches. And to minimize cost, you choose a postal service that limits the size of the packages. So the length plus the width plus the height may not exceed 66 inches. So the question is, can you find the largest volume possible that you can mail? So let's see how to do this problem. So the first step here should be to detect what is the function that we want to maximize. So we go to our problem and we see that we want to maximize the volume. So, well, we have a box that is S by S by L, so maybe let's start drawing an example. So our box looks like this, and we know that is S by S by L. Okay? So the volume of this box will be S times S times S, which is the same as saying S squared L. The problem here is that we cannot find the maximum of this function because it's a function involving two variables. So we need to do something to get rid of one of them to write it in terms of the other. To do so, we need to find the restrictions that are given inside our problem. The restriction in this case is that the size, so the length plus width plus height, may not exceed 66 inches. So the size, which is equal to S plus S plus L, has to be equal to 66, which is the same as saying that 2S plus L is equal to 66. From here, we can obtain that L is equal to 66 minus 2S. And now we can use this, putting it back in our volume function. So we end that the volume is S squared times L, but we just found that L is equal to 66 minus 2S, so the volume is S squared times 66 minus 2S. We can expand this and obtain that this is 66S squared minus 2S cubed. So now our volume function is a function that depends only on S, and even more, if you notice on the problem, S has to be between 0 and 33. If not, if S was bigger than 33, the length would have to be negative, which in our case makes no sense. So we can restrict the domain of our problem to a close interval between 0 and 33. So now we need to maximize this function. So as always, the first step should be to find the first derivative of this function. And we need to solve this to be equal to 0. So we can factor this as S times 2 times 66 minus 6S, and this to be equal to 0. From this we need to obtain the critical values. So one critical value is S equals 0, and the other critical value is x equal 22. So now that we found our critical values, and in fact all these critical values are relevant to our problem, so 0 and 22 are both in the interval we want to study, we need to find what is the maximum. So to do so, remember, with the closed interval method, we can just evaluate all the critical values and the endpoints of the interval. So in this case, we need to find what is v of 0, what is v of 22, and what is v of 33. So notice that in this case, v of 0 is equal to 0, v of 33 it's also equal to 0. So we only need to find what is v of 22. And v of 22 will be equal to 10,648. So this is the absolute maximum. So going back to our question, the largest buck will be obtained when S is equal to 22, and so L will also be equal to 22, and the volume will be equal to 10,648 inches